Measures of variability describe the dispersion or spread in scores for a measured variable. These measures are used with interval or ratio level variables. This presentation focuses on 4 such measures: range, variance, standard deviation, and interquartile range. The range represents the largest score in a dataset minus the smallest score. It is a very simple measure that provides a quick idea of how spread out your data are, but it is also very limited in that it ignores all but the 2 outermost values. Let's take an example. Suppose we are studying resting heart rate in a sample of undergraduate college students. The variable of interest is heart rate, measured in beats per minute. Here are the data for each of 7 subjects. The range is simply the difference between the largest and smallest scores. In this case, 9 beats per minute. Unlike the range, the variance takes into account all of the data. It is defined as the average squared deviation from the mean. This is the definitional formula for the variance. We use s squared to represent the sample variance. Looking at the numerator, we can see that each score, x, is included in the formula. The mean is subtracted from each score, squared, and then summed across all scores. The sum of squared mean deviations is then divided by n-1 to get an average. You might be wondering why we divide by n-1 and not n. It is because we use the sample variance as an estimate of our population variance, and dividing by n-1 gives us a better estimate. The variance is a good measure of the variability or spread of a set of scores, but it has a downside. It is measured in squared units. So for the heart rate example, the variance is 11.9 squared beats per minute. No matter what the units of measurement, variance is always the square of that unit. So while the variance is an important measure for inferential statistics, it's not an intuitive measure for describing variability, and is seldom used for this purpose. Instead, we generally report the standard deviation. The standard deviation is the square root of the variance and puts the variable back into its original measurement units. So for the heart rate data, the standard deviation is 3.45 beats per minute. On average, heart rate varies around the mean, plus or minus about 3.5 beats per minute. Higher values for the standard deviation reflect more variability or spread in the data. The standard deviation is the most commonly reported descriptive statistic for variability. You will generally see it reported in tables as either S or SD. Here is an example of a table of descriptive statistics for a study on the effects of frontal lobe strokes on problem solving and decision making. This table shows means and standard deviations for 3 variables, reported separately for men and women. Descriptive statistics are especially informative when comparing groups of subjects. Looking at age for men and women, we can see that they do not seem to differ in terms of the mean. But there is more variability for women than for men, indicating that there is a wider range in age for women. A graphical representation of the relationship might look like this. The means, reflecting central tendency, are pretty similar. However, there is more spread in the distribution for women than for men. This can be seen more clearly when a vertical line is drawn from the end of the first distribution down to the second. On average, women completed more education. But there is also more variability around the mean for women than for men. In this case, both the center and the spread are higher for women. Finally, the mean time since injury is higher by nearly 2 months for men. But the standard deviation is higher for women. So the mean is higher for men, but the variability about the mean is higher for women. The final measure of variability for this presentation is the interquartile range, which, as its name suggests, is determined using quartiles. If you've ever taken a standardized test, you probably know what a percentile is. If you scored in the 80th percentile, it means that your score was higher than 80% of those taking the test, and that only 20% scored higher than you. Percentiles break a distribution into hundredths. Quartiles, on the other hand, divide an ordered distribution into 4 equal segments. We already know that the median is at the center of an ordered distribution, representing the 50th percentile. It is also referred to as Q2. Q1, the 25th percentile, represents the median of the lower half of the distribution, and Q3, corresponding to the 75th percentile, represents the median of the upper half. The interquartile range is obtained by subtracting the lower quartile from the upper quartile. As a measure of dispersion, the interquartile range is analogous to the range. The difference is that it focuses only on the middle half of the distribution. While it is not often used as a descriptive measure of variability, the interquartile range is a very useful tool in determining outliers. In addition, box and whisker plots are drawn on the basis of quartiles, so an understanding of the interquartile range is critical in interpreting these plots. To summarize, measures of variability describe the dispersion or spread in scores for a quantitative variable. The range represents the difference between the largest and smallest scores. It is the easiest measure to calculate, but also the least useful. The variance is the average squared deviation of each score from the mean. It is a better measure than the range because it takes into account all scores. But it is difficult to interpret, so it is usually not used as a descriptive measure of variability. Its main application is in inferential statistics. The standard deviation is calculated by taking the square root of the variance. While the variance is reported in squared units of measurement, the standard deviation is reported in original measurement units, thereby making it much more useful for describing dispersion. Just as the mean is the most reported descriptive measure of central tendency, the standard deviation is the most reported descriptive statistic for variability. Finally, the interquartile range represents the range of values in the middle of an ordered set of scores. It is useful in determining whether there are any outliers, and is also the basis for the box and whisker plot.